Welcome to Lesson 18. We're going to continue to talk about transformations. So let's review a little bit about what transformations might be. We've talked about dilations, and those are vertical stretches or shrinkage when essentially a graph either widens or narrows down by a scale. So I have my parent graph here. My parent equation is x squared. So it's going to be a quadratic equation, which means we're going to get a parabola, and we'll talk more about quadratic equations in future lessons. But I'm going to apply a scale of 1/2. And what that does to the graph is it makes it wider, which is kind of counterintuitive. When you have a scale factor that is less than 1, you would think it makes items smaller, and it does, right? The points actually end up being smaller, but visually it widens the graph. There you see a comparison between the two graphs. The red one is the parent graph, and the dilated graph is the blue one with a scale of 1/2. Now, what would happen if I use a scale of 2? And in this case, of course, you know that because 2 is greater than 1, then it's going to make the order pairs, the y specifically, larger. So it's going to get narrower as it goes up the y-axis a lot faster. So these types of dilations are also commonly referred to as vertical stretches or shrinkages, because vertically, meaning up and down the y-axis, these numbers are shrinking or stretching. The next type of transformation that you learned about was a reflection. And specifically, you learned about a reflection across the x-axis. And that occurs when we change the sign of the leading coefficient. So we add a negative sign to our parent function, which is x squared. And now we have negative x squared. And that, of course, will reflect it across the x-axis. That's the purple graph that you see. And the last type of transformation we have learned is translation. And you have learned about up and down translations, up and down the y-axis. When we have a parent graph, like you see here, the vertex is 0, 0. And we shifted it down, and now we're shifting it up the y-axis. So the vertex then changes, the y value changes to a 2. So what we're going to do is we're going to look at additional interesting transformations. So these are transformations we have not seen before. And as I do these and we do these together, these are the questions that I would like for you to keep in mind. How is the parent graph related to these new equations? And what are the new coordinates for the vertex in each transformation? We're going to use a quadratic. So we're going to use that parabola graph that looks like a U. So our parent function is going to be an x squared, so that you're able to, sometimes it's a lot easier to see these transformation with that type of graph. But these types of transformation occurs for all graphs, not just the parabolas. So let's get started. I have my parent graph here, which is x squared. And what I'm going to do is I'm going to specifically get the points so that we're able to compare them numerically first before we look at the graph. So if x is -3, x squared would be 9. If x is -2, then of course you know what x squared would be. And then I'm just putting in my graph, double checking that those order pairs are there. So for x is -3, there I see that my -3 value is at 9. Perfect. Now, I want to know if I subtract 3 from x before I square it. There's a huge difference in here of subtracting before you square it as opposed to after you square it. So let's go ahead and do it. Let's plug it in. -3, which is your original x, let's subtract 3 from it, and that actually gives you a -6, and then let's square it, and then we get a positive 36 when that happens. Seems like unusually high. However, when you plug in the numbers, it works. Now, what would that look like in a graph? What did you notice just happened? This parabola, our vertex was at 0, 0 before, and now our vertex is at 3, 0. The parabola moved to the right 3 spaces when we subtracted 3 from the x before we squared it. Because it's moving through the x-axis, it's called a translation, just like the one that is moving up and down the y-axis. Please populate the rest of these 2 tables with these other transformations so that we can continue to discuss in the next video.